Hello, everybody. So today we're going to learn how to identify increasing and decreasing functions. So honestly, these isn't that bad, to be honest with you. All you really need to know is that um, we read the functions from left to right, the same thing as you guys read a book. So right here, I can see that if this was my function right here, let's call this one. This was my function, it's called f of x. Um, Pretty much like a roller coaster, it looks like it'll be going up. So that's pretty much what I'm saying, increasing function. Same goes here. If you have a roller coaster right here, you start on the left-hand side and you go that way. You can see the height is decreasing, right? Because you started here at the top and you finished here at the bottom. Started from the bottom, now we're here, right? Well, actually, this one, right? Okay. What I also want to talk about is intervals. So we need to talk about like, oh, well, it increases from a certain amount and then it decreases from a certain amount or whatever the case may be. So look at this function right here. Go ahead and pause the video and find out what is the increasing part. So write it in intervals, the same thing you do for domain and range. Okay, so right here, I can see that this right here, this quadratic function, my x squared, remember this is a parabola, so x squared. And I have this right here. I can see that this right here, my roller coaster was right here, all up to here, right? All of this area right here, I'm going down, right? So this is decreasing. So I'm decreasing. Keep in mind, I should have put arrows here, but keep in mind, this is going all the way up. So it doesn't necessarily just stop right there, but all the way left. So what's the farthest left I can go? So I'm actually answering this one because it's decreasing. So the farthest left I can go is negative infinity, right? Because this parabola. And then I'm going to go ahead and decrease, 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 decrease all the way to this point right here. And that is 0. Okay. You can put parentheses or brackets on the 0. To me, it really doesn't matter. But the one that does matter is infinity. That one always has a parentheses. And you might be wondering why. Well, this has a little bit to do with the way you look at it in physics. If I was to get a ball and I throw it up in the air, it would usually go all the way up, 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 up. And then there'll be a point where it pauses and then just goes back down, right? Because of gravity. Same way you shoot the basketball, it goes up and then curves back down. So at that very instance, we cannot say it's increasing or decreasing. So that's the reason why. So if you put a bracket on that 0, you're good, or if you put a parentheses, you're good. So the other part right here, it is going up, 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 all the way into infinity. So this is from 0, right? Because here's the part where it stopped. So it stopped decreasing and started increasing. So 0 to infinity. And same thing. Easy peasy stuff. Not that bad. Where can you see this? Well, right now, you can probably see this the most is in stocks, especially these right here. I just picked a couple of them due to this relevant time. You know, a lot of companies have had to go online, and just like you're doing right now, you're trying to learn online, and you can see that around this area right here, you can really see that COVID was happening. So a lot of companies that were doing digital learning, like Zoom, just skyrocketed. Kid you not. Same for Microsoft. Others that did not are probably like the oil companies, cruise companies, and airline companies. So you can clearly see how they are right here. This area specifically, they are decreasing. So time to buy, right? So pretty much the next thing we can see is that if some function is increasing, right? If it's increasing and then decreasing, you have a max. And it looks like a little hill like that on your function. Minimums are the opposite. Something is decreasing and then increases. And you should see it as a little dip, right? This point right here is a minimum. This point right here is a max. Easy peasy stuff, guys. And you'll see them in your functions. They're usually graphs, and then later on through the year, I'll teach you how to do it algebraically, and it's super fun. All right. Are these maximums and minimums all created equal? Well, not exactly. The more common way that you'll see maxes and minimums in my class are called extrema. And if you pursue to see math during your college years, that's how they will talk about them. So there's two types, absolute extrema. Some people call it global extrema. To me, absolute is fine. The next one is local. So you've already seen this, believe it or not, you've seen in Algebra 2, maybe even geometry, but absolute extrema means the highest or the lowest max or min. So absolute means if it's you're talking about a max, it's the max you can go. If you're talking about a min, it's the min you can go. So let's go ahead and try this example because it has all four scenarios. So first of all, let's try finding all the maxes. So this right here, I'm gonna say it's a max, right? And hopefully you can agree that this right here is also a max. Very confusing because we don't see this other side, but it's still a max, right? By definition, we can see that these right here, this point right here, would be a minimum. This point right here would be a minimum. Okay. So we have all scenarios here. So remember, if I am talking about my absolute max, that means the highest of the highest or the lowest of the lowest. So this right here, this max right here is higher than this max right here. So this is my absolute max because it's the highest of the highest. My minimum, my absolute minimum is the lowest of the lowest, which is right here. So the highest of the highest or the lowest of the lowest. Keep in mind that not all functions need to have them. I think that's where my students were confused last year. Local extrema. Okay, so local extrema means it's just a max or it's just a min, not necessarily the highest. So everything that is not an absolute is a local. Say local. This always happens when you have endpoints. So right here, these are endpoints. Very important in calculus. And so be expected to have absolutes when you have that. Last but not least, guys, what you need to learn is a boundedness. So whenever you have endpoints, guys, let me see, these endpoints, right? The function stopped, right? It didn't continue out of my screen. It stopped. And we can see we're going to have boundedness, meaning your function is restricted. In other words, if you put your pencil on top of that function, if you put your pencils right here on top of the function, it won't pass it. Or if you put the pencil in the bottom of the function, it won't cross it. So let's look at this one. So if I was to put a line right at the top, right here, will this function pass it? No, because it has these right here, these endpoints, meaning the function stops at its height. So it is bounded above. This is called bounded above. Now, can we put a little dotted line at the bottom? If we can, and the function does not cross it, is bounded below. So we can see that if it's bounded above and it's bounded below, automatically it's bounded. So you just have to write this, bounded, if it's both. If both above and below, it is automatically, oh, that's all you have to say, bounded. And of course, if this was like, let's say, continuing to infinities, right? Infinities and beyond, then it's not bounded because no matter what line I draw, let's say I draw a line right here, this is telling me it'll go up, 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 right? My range is negative infinity to positive infinity. So no matter what, it's gonna go all the way up and all the way down. Okay. So I only have one example for today, and let's go ahead and do this right here. So automatically, what I tell my students is just draw it on the picture. So this right here, very important. This is all the way up, okay? Then I'm checking this out. This looks like a little min. There's like a little change, right? It's the x-intercept. This right here is a max, right? Okay. The next thing I'm going to go ahead and do is write where it's decreasing, where it's increasing. So let me pick a different marker. This right here is decreasing. All of this area right here is increasing, and then again decreasing. So let's write the interval. At what part is it increasing? Well, increasing, we just saw, is from this x value, -1, all the way to this x value 1. So it is increasing from -1 to 1. What value is it decreasing? Well, alternatively, it will be this, from this 1 all the way left, right? Because we're talking about x's. You know, all my x's live in the domain, right? So it's all the way left, so -infinity, all the way to the where it stops decreasing, right? Because this is decreasing. -1, union. Where else does it decrease? Well, we can see it right here. This is decreasing from 1 to infinity. So whenever you have two parts that are decreasing, you put this little u, just say, combining both parts. All right, are there any local extrema? Are there any local extrema? Well, that just means a max or a min that are not absolute. So this right here is local, and this right here is local, because they are not the highest point and they're not the lowest point, because this arrow right here means that there's still, the function's going down, and this arrow right here means the function's still going up. So this is local extrema, and you can put that point. That point right here is my x value, -1, comma, and my height is -2. So the location, that is my min, and my max is this point right here, which is, appears to be 1 to the right, 2 up. So it's going to be 1 and 2. Is there any absolute extremis? Well, remember, this went all the way up, 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 and all the way down, 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 down. So there is none, and that's perfectly fine. Is the function bounded? Well, according to our notes, means I could draw a little line, do it in red, and it will pass this line right here. Will it pass this line? If it does, it is not bounded. So since it's going all the way up, it's not bounded on top. And if it crosses this line at the bottom, it's not bounded below. So this is not bounded at all. That's all that I have for you guys. In your notebook, I went ahead and dropped off a similar example. I believe there's two, and that's all that I have for you.